Hello all, welcome to my channel. Let's continue with the C Sharp interview series. Today's topic is exception handling. So what are exceptions? So basically exceptions are types only and these are derived from the class system.exception. So basically exceptions come in place when there is any error in the program. For example, I'll show you. See here, I am declaring an array of size 3, and now I'm trying to access. Okay, here I declared an array whose size is 3. So possible indexes would be only till 2, right? 0, 1, 2. So but I'm trying to access an index which is not possible. So this will not give any error during the compile time. This causes a error during the run time. So when I run the program, this error gets identified, not during the compile time. So runtime errors cause exceptions. So if you see here, exception is caused and it is giving us index out of range exception. So basically because of this runtime exceptions, program will be stopped abruptly. So functionality will be stopped. So there should be some way to handle this exceptions. So C Sharp has few. Okay, C Sharp has a specific way to handle this kind of exception. So we use try, catch, and finally blocks to handle this exception. So let's start with this. So what is a try block? So we will just enclose all the possible statements that might give any exception inside the try block. So basically a try block is used to partition code that might be affected by an exception. So if we just write the code inside a try block, if I show you here, so here this line of code is giving us exception. So we'll just put this code inside try block. So basically what does this mean is we'll just enclose all the possible code that might give us exceptions inside try block. So if exception occurs in try block, then flow of control jumps to the first association exception handler anywhere in the call stack. So basically try block will not exist independently. If you see here, I gave try but it is giving me error. See, expected, catch, or finally. So whenever there is any exception, we have to give enclose the code, enclose the possible code inside try block, and we should also give the exception handler. So that is catch. Exception handler is catch or finally. So we'll see what it is in detail. So a try block without a catch or finally block causes a compilation error. So this will be a compile time error only. So when we are writing the code itself, the control flow will just highlight us saying try cannot exist independently. So we have to add a handler. We have to either add catch or finally. If we add both also, that will not create any issue. So this is about try block. So let me show you here the flow. So here I added a try and I gave here. So let me put a debugger here. Debugger is nothing but it will just help you run the code line by line. So I'm running this. So control came here. So I came to the next line. So it is giving me exception. So as I said, once any exception happens, control will come into the catch block. So this is how it happens. So control will be in the catch block. I'll remove the debugger and let's see how that works. See, if you see here, it gave me the output saying we just printed the exception here. What is the exception? So now if there is no any error. For example, we estimated there would be some error in the code, but there is no error. So in that case, what happens? So I just removed the line that is causing issue. So let's see what happens in that case. So here controller started, and so it simply comes out of the try block. So if there is any exception, then only it goes into the catch block. If there is no exception, then it simply executes the code inside the try block, and then it comes out of the method. So this is about try. And let's start with the catch. So catch keyword, as I said, it is used as a exception handler, and multiple catch blocks are also allowed. So I can give here multiple catch blocks as well. So let me add catch. So I am just specifying the exception name directly here. If you see in the previous catch, we gave the generalized class name exception. So this exception covers all the possible exceptions. So if you wanted to make it more specific, then you can give the name of the exception directly. So you can give how many ever catches, I mean how many catches you wanted, that many you can give here. But make sure here the exception that you specify should be from most specific to the least specific. So as I said, it's important to position catch blocks with the most specific exception classes first. And you can specify exception filters to add a boolean expression to a catch class. So you can add a boolean as well. For example, here what I wanted to do is, let me write two scenarios. Test array of -1, test array of 4. So here two cases are there. Index of negative number is not possible, right? It will obviously give an error, but it doesn't highlight it during the compile time, so it will obviously cause an exception. So control will be moved from try to catch. So it will just check for the most specific catch one after the other. For example, if any of the exception matches, for example it matches with the first catch, no, only one catch will be executed, it will skip the other catches. So now what I wanted to tell is, here we can use boolean expressions as well. Here what I wanted to tell, okay, let me give here index 1 equal to -1 and int index 2 equal to 4. Okay, here let's use index 1 and index 2. So in real time, no, these values will be varying, right? We will not be knowing which value exactly comes here in real time. Okay, for now we are hard coding. So here I wanted index, when index 1 is less than 0. If index 1 is less than 0, then just print saying negative numbers not allowed. When index 2 is greater than 3, maximum limit reached. So here I can give as many catches I wanted, and as I said, only one catch will be executed. And one more point to note is, if any exception happens, for example, okay, I'll show you with when I'll just run it and show you so that you will get more clarity. So here it started, and as I told, here it will give me an exception. So this line will cause me an exception. So it will search for the relevant catch block. So here this is the, so as this is the relevant catch block, this catch gets executed. So as I said, if one catch is executed, it will abruptly come out of, I mean, it will not check for the other catches. Only one catch gets executed, only the most relevant catch gets executed. And if you see the line, the code of line that is after the exception, I mean, here this line caused me exception. So after this line, whatever code is there, that gets skipped, that will not be executed. See, if you see, the control comes out of the method. See, negative numbers not allowed is printed in the console. So now let me comment this line. So okay, wait. So as I said, it should be from, okay, so here this is how. Now let me make this second one executed. So if you see, it gave me error. So, and the second catch block is executed and it comes out of the loop, I mean, it comes out of the method. So this is how this works. So catch, let me reiterate the points for you. So whenever an exception occurs, we use the functionality that is there in C# is exception handling, and we use try, catch, finally, and throw for exception handling. So majorly it is try and catch. These are the two that play important role in exception handling. So try block is nothing but you just enclose the code that is possible for errors inside the try block. So whenever any exception happens inside the try block, the control flow moves from try to catch. So catch is nothing but an exception handler. Next finally. So finally is nothing but when you write any code in the finally block, it just executes irrespective of any exception. So how, if when we see catch, catch gets executed only if any exception happens in the try block, right? So but finally is not the case. Finally executes whether any exception happens or not. So you can write try with catch, or you can write try with finally, or you can write try, catch, and finally also. Now let me show you example of finally. So here let me add finally block here. So if you see how this finally works is, okay, now exception happened, catch is executed, and then it came into finally, right? So the flow is like this: try, if any exception happens, it comes to catch, and then finally gets executed. Now I'll just comment the code that is causing exception. So as there is no exception, catch block is skipped. and it will directly come to the finally. So since finally gets executed irrespective of the exception, no, finally is generally used to clean resources. For example, if any file is opened inside try block, then you can close those resources in the finally block. Or if any data connection or if any database connection is opened in the try block, as database connections server, it will have very limited count, I mean very limited connections will be allowed, na? So to waste I mean we can just close the database connections in finally block. And throw is nothing but you can explicitly throw an any exception. For example, if I here here I commented this, but I can explicitly throw exception here. So let me show you. Throw keyword will be used to explicitly throw an exception. So as I said, exception is object itself. Exception is object. So if you wanted to throw any exception, you have to create an object of that exception and throw it. So when I throw any exception object, as I said, it is similar to causing an exception only. So it will directly jump to the relevant catch block. And then finally, so this is how throw works. So yeah, and then here it comes the custom exceptions. So till now, whatever exceptions we have seen, here we have seen index out of range exception, and similar to this there are many inbuilt or exceptions that are possible exceptions that are provided by the C sharp. So we have used only inbuilt exceptions. If we wanted, we can generate custom exceptions, and we can throw those custom exceptions also according to our requirement. So basically, whenever an interviewer asks you about the exception handling, no, you have to iterate these points about try, catch, finally, and throw. So let me give you an example of this custom exception as well. So custom exception is nothing but you have to just create your own exception. Okay, so now I am creating a class called custom. So as I said, exception is object, so exception is a type only, so it has a class. So for that you have to create a your own exception class and create an object for your own exception class, but the condition is you must inherit the root exception class, and you have to create constructor as well for this. So you have to just see, as I said, you have to just create a class, inherit that exception class, and that is how it works. So this you can directly create object of this and use. So I'll just create a class. So here I'll write a try block, and I'll just call this method. Oh, sorry, here I have to create an object. let me make this static otherwise. Okay, fine. So now, so static, as you, I mean, I will be going through OOPS concepts in detail in the coming classes. For now, let's try to understand that if we give a static keyword, no, it will just act as a class level functionality, not an instance level. So you can directly access it using the class, using class name, or you can directly call it with the method name. Okay, fine. Now what we where we are, so I'm calling this exception, and then let me give the catch. Okay, let me print this. Wait. Okay, why is it this not? Yeah, okay. So we created a custom exception, and when we try to run here, oh ये क्या हो गया? Okay, wait. Yeah, sorry, here I have to, so here I have to throw new exception. So here, so here data is data contains exception. So since this causes exception, see, if you see here, console app dot program dot custom exception, it gave us the custom exception that we have created. The exception type is this. So when I run on continue, so it just prints the exception that is created. See, exception of type console.program plus custom exception was thrown. So this is about custom exceptions. So there's one more point. Generally in exceptions there are a few methods that we commonly use. For example, e.message, it gives us the exception message, and if I give e.stack trace, so it will give us the entire stack trace of that exception. So basically, stack trace is nothing but when there is a continuous chain of calls happening. So in the third call, if exception happened, so it will just go to the stack trace, and it will give us the exact method and line where the exception happened, and this exception is carry forwarded till the first call. Yeah, this is about exceptions. So this is a small topic only, but it's important topic because in real time this is very much needed. So if you start working on any project, no, exception handling is a must, because we cannot expect this kind of, I mean, functionality getting stopped abruptly without any handler there. So that is not an ideal scenario in real time. So whichever project you go, you will be seeing exception handling in place for .NET projects. So this is about exception handling. So guys, please support for my work, and please like, share, support and subscribe. And if you wish me to continue on this series with more enthusiasm, just support me. And thanks a lot. Thanks for watching.